Good morning. My name is Meenakshi. I am from BSc Chemistry, honors second year. My topic is classification of phenols. What is phenols? Phenol is an aromatic organic compound. Phenol is an aromatic compound. It is formula C6H5OH. White. It is white crystalline solid that is volatile. The molecule consists of the molecule consists of a phenyl group bonded of hydroxy group. Depend on the number of hydroxy group attested. Phenol can be classified into three types: monohydric phenols, dihydric phenol, or trihydric phenol. First, monohydric phenol. They contain one OH group are called monohydric phenol. Second, dihydric phenols. They contain two OH group are called monohydric phenol. Trihydric phenols. They contain three OH group. Some preparation of phenols. First step from alloherins. Chlorobenzene is an example. Of haloarines. The chlorobenzene reacted with sodium hydroxide at 6 to 23 degrees Celsius and 320 atmospheric pressure are made sodium phenoxide. Finally, the sodium phenoxide are acidification to make phenols. Second, Dawes process. The Dawes process used to preparation of phenols, in which chlorobenzene react with sodium hydroxide with under the pressure obtain phenol. Thank you.
Good morning, myself Shiksha from chemistry honor second year. My presentation topic is law of absorption. There is three law of absorption. The first one is Beer's law. It states that the amount of monochromatic light is directly proportional to the concentration of the substance. Its formula is logarithm I upon I naught directly proportional to C. Here I is the amount of absorbed light and I naught is the amount of light before absorption. The second one is Lambert's law. It states that the amount of monochromatic light is directly proportional to the number of molecules present in the path length of that substance. Similarly, their formula is logarithm I upon I naught directly proportional to length. The third one is the third and the last law is Beer-Lambert's law. It is the combination of Beer's and Lambert's law. It states that the amount of monochromatic light is directly proportional to the concentration as well as the path length of the substance. Here's formula is logarithm I upon I naught directly proportional to length and the concentration of the substance. There is one limitation of Beer-Lambert's law. That it fails at higher concentrations because the linearity of this law is limited for any chemical substance. Thank you.
Next, Arjun. Start with-
Good morning, all of you. I am Anu from BSc Chemistry Honors second year. Today, my presentation topic is ether and its classification. Ether, those compounds which contain O functional group in their structure are called ethers. Further, ether is classified into two types: acyclic ether and cyclic ether. Acyclic ether, the ether which do not contain O functional group in the chain in the cyclic structure. Cyclic ether, the ether which contain O functional group in the ring of carbon atom. Further, acyclic ether is classified into two types: aliphatic ether and aromatic ether. Aliphatic ether, the compounds in which substituent around the O functional group are alkyl group are called aliphatic ether. Aromatic ether, the compound in which substituent around O functional group are aryl group are called aromatic ether. Further, aliphatic and aromatic ether are classified into two types: symmetrical ether and unsymmetrical ether. Symmetrical ether, the compounds in which substituent around the O functional group are same, are called symmetrical ether. Unsymmetrical ether, the compounds in which substituent around the O functional group are different, are called unsymmetrical ether. Further, symmetrical and unsymmetrical ether are classified into three types: dialkyl ether, diaryl ether, alkyl aryl ether. Further, cyclic ether are classified into simple cyclic ether and crown ether. Simple cyclic ether, the compounds in which 1 to 3 oxygen atom are present in a cyclic ring, are called simple cyclic ether. Crown ether, the compounds in which 4 or more oxygen atom are present in the cyclic ring, are called crown ether. Thank you.
Arjun.
Good morning, everyone. Myself Swati from BSc Chemistry second year. My presentation topic is alcohol and its classification. Alcohols. Firstly, we discuss about alcohols. Alcohols are those species which are formed by the replacement of one or more hydrogen atom from the aliphatic hydrocarbon or from the side chain of the aromatic hydrocarbons by the OH group. Now, physical properties of alcohols. Alcohols are existing in liquid state. Alcohols have high viscosity and have high boiling point. Alcohols are soluble in water and alcohol shows hydrogen bonding. Alcohols are classified in different ways. There are first way of classification. According to its first way of classification, there are two types of alcohols: aliphatic alcohols or aromatic alcohols. Aliphatic alcohols are those alcohols which are formed by the replacement of one or more hydrogen atom from the OH group from the aliphatic hydrocarbons, and aromatic alcohols are formed by the replacement of one or more hydrogen atom from the side chain of the aromatic hydrocarbons. According to its second way of classification, there are three types of alcohols: monohydric, dihydric, or trihydric. Monohydric, the carbon atoms which have the alcohols which have only one OH group are present are called monohydric. Example, ethanol. And the alcohols which have two OH group are present are called dihydric. And the alcohols which have three OH group are present are called trihydric. Monohydric alcohol is further classified in three types: primary alcohol, secondary or tertiary alcohol. Primary alcohol, the alcohol in which the OH group is further linked with one or no carbon atoms. Example, methanol. Now, secondary alcohol are those alcohol in which the carbon atom is further linked with two or more carbon atoms. And now, tertiary alcohol are those alcohol in which the carbon atom is further linked with three or more carbon atoms. For example, 2-methyl butane. Thank you.
Good morning, everyone. I am Mamta from BSc Chemistry Honors second year. My today's presentation topic is ether and their classifications. Ethers are those compounds in which contains O atom as a functional group in their structures. Ether are further classified into two types: acyclic ether or cyclic ether. Acyclic ether are those type of ethers in which O atoms O functional group is not present in the cyclic in the cyclic ring. And the cyclic ethers are those compounds, those ethers in which the O functional group is present in the cyclic ring. Further, a cyclic ether is further divided into two parts: aliphatic ethers or aromatic ethers. Aliphatic ethers are those ethers in which the substituents around the O functional group are aliphatic alkyl groups are called aliphatic ethers, and the aromatic ethers are those ethers in which the substituents around the functional group are aryl group are called aromatic ethers. And the further aromatic or aliphatic groups are further divided into two parts: symmetrical ether or unsymmetrical ether. Symmetrical ether are the ethers which contains same substituents around the functional groups are called symmetrical ethers. And unsymmetrical ethers are those type of ethers which contains substituents around the O functional group are different substituents are called unsymmetrical ethers. On the cyclic ethers are further divided into two parts: simple cyclic ethers and crown type cyclic ethers. Simple cyclic ethers are those types of ethers which contains 1 to 3 O atoms in the carbon present in the cyclic ring are called simple cyclic ethers. And the crown type cyclic ethers are those type of ethers which contains four or more oxygen atoms in carbon in cyclic ring are called crown type cyclic ethers. Thank you.
Hadi beta next time.
Hello everyone, I am Vanda from BSc Chemistry on second year. Today my presentation topic is electrophilic substitution of phenol. As you know, phenols are the hydroxy derivatives of aromatics compounds in which OH group is directly attached to the aromatic ring. Electrophilic substitutions are of many types. First one is the bromidation, and bromidation. When phenol is treated with aqueous bromine water, then when phenol is treated with bromine water, that is aqueous bromine water, and then 2,4,6 bromophenol is formed. The other is the nitration of phenol. When phenol is treated with concentrated H2SO4 plus concentrated HNO3, then picric acid is formed. That is 2,4,6 tribromophenol. The other one reaction is when phenol is treated with dilute HNO3 at a temperature of 293 Kelvin, then ortho and para nitrophenols are formed. But here the yield is very poor because nitrating mixture, that is dilute HNO3, they also oxidize the phenol. The other one, electrophilic substitution reaction, sulfonation. When phenol is treated with concentrated H2SO4 at a temperature of 288 Kelvin, then ortho products are formed, and 2-phenol sulfonic acid is formed. And when phenol is treated with concentrated H2SO4, then at a temperature of 373 Kelvin, our para, that is 6 phenol sulfonic acid is formed. At the other one is Friedel-Crafts acylation, Friedel-Crafts alkylation, Gattermann synthesis, and Hoban-Horsch reaction. Thank you.
Good afternoon. This is Sonam from Chemistry Honors second year, and my topic is ethers. Ethers in which the oxygen atom is present uh, with single bonded atoms.
आराम से बोलिए.
Ethers, physical properties of ethers. Ethers are less soluble in water, but they are good solvent in organic reactions. And ethers have weak van der Waals forces. Smaller ethers, for example, diethyl ether and ethyl methyl ether are gases, and the left all other ethers are colorless liquids. Preparation of ethers. Two important methods for preparation of ethers are Williamson synthesis, and second is from alcohol. We use alcohol in presence of H2SO4 at a specific temperature of 413 Kelvin. 413 Kelvin, we get symmetrical ethers. In Williamson synthesis, we use alkyl halide and sodium alkoxide. And we get NaX as a side product and ethers. Thank you.
आ जाओ. जल्दी करो.
Good afternoon, everyone. My name is Anuj from BSc Chemistry Honors second year. Today, my presentation is on alcohols and its classification. Alcohols, the species which are formed by the replacement of one or more H atoms of aliphatic hydrocarbons or side ring of benzenes by hydroxyl group is called alcohols. Alcohols are the classification of alcohols. First is aliphatic alcohols or aromatic alcohols. Aliphatic alcohols, the alcohols which are formed by the replacement of one or more H atoms by aliphatic hydrocarbons by hydroxyl group is called aromatic alcohols. Example is methanol. Second is aromatic alcohols, the alcohols which are formed by the replacement of one or more H atoms from the side ring of benzene by hydroxyl group is called aromatic alcohols. For example, benzyl alcohol. The second classification of alcohol is monohydric alcohols, dihydric alcohols, and trihydric alcohols. Monohydric alcohols, the alcohols which contain only one OH group are called monohydric alcohols. Example is ethanol. Second is dihydric alcohols. The alcohols which contain two OH groups are called dihydric alcohols. For example, glycol. Third is trihydric alcohols. The alcohols which contain three OH groups are called trihydric alcohols. For example, glycerol. Thank you.
आ जाओ.
Good afternoon, everyone. My name is Rohit from BSc Chemistry Honors second year. Today's my topic for presentation is alcohol and its classification. Alcohol, the species which are formed by the replacement of one or more H atoms from chain of aliphatic hydrocarbon or the side chain of benzene ring from aromatic hydrocarbons by hydroxyl group. For example, methanol. Classification. Alcohol is classified in many ways. First way of classification is aromatic alcohol and aliphatic alcohol. Aliphatic alcohol. The alcohol which are formed by the replacement of one or more H atoms from replacement of one or more H atom from the chain of aliphatic hydrocarbons. For example, methanol. Aromatic alcohol, the alcohol which are formed by the replacement of one or more H atom from the side chain of benzene ring in aromatic hydrocarbons. For example, benzyl alcohol. Second way of classification, monohydric alcohol. The alcohol monohydric alcohol. The alcohol which contains only one OH group is called monohydric alcohol. Dihydric alcohol, in this species there are only two OH groups in this. For example, glycerol. Trihydric alcohol, in this there are three OH groups. There are three OH groups in this compound. For example, glycerol. Thank you.